Okay, welcome to this video. In this video, we are going to prepare for the November mock, and we have a selection of questions from the class. We're going to be looking at libraries, the little man computing, and trying to turn that into an algorithm. We're going to look at tracing a recursive algorithm, and we're going to look at software methodologies, waterfall and spiral, I believe. Anyway, the first question is all around when Imogen creates programs in a high-level language. By high-level language, we mean what, people? Python would be an example, C++, C#, Java. Now, what's an example of a low-level language? Yeah, so assembly code would be an example of low-level. And essentially, it's closer to how the machine works itself. You remember in assembly code, you've got sorry, in an instruction, you have an opcode and an operand. So you might have something like, I don't know, as example, add would be an opcode, and then, I don't know, 36 could be a memory location where it's going to add to an operand. And then in assembly, it's written like this, and it's a one-to-one. You change an instruction to an assembly instruction to a machine instruction, and it converts quite easily. And high-level code, you'll have one line like this if A is greater than 6, and that could lead to a whole bunch of lines associated with it, yes? So that's a high-level language. And high-level languages, one of the benefits it has are these things called libraries. So in the code that you write, you pretty much have to write the code from scratch every single time. Having said that, do you sometimes at the top in Java go import and import something? Yes. Yeah. What sort of things have you imported? Random. Anything else? Go on. Array list. Absolutely. Anything else? Scanner. So let's explore each of these. All of those are libraries. Okay. Random is a library that you can bring in that has a whole bunch of different functionality that allows you to do randomized numbers, sets random seeds, does a whole bunch of things around random. Scanner, we use it to import from the console. You can actually do a whole bunch of things with the scanner library. You can import from text files. You can do outputs of a particular type to text files, not just input and output to the console, but to you as well. What was the other example? Array lists. So you can import the array list data structure as a library that you can then make use of. And there's other ones you can have. Common ones out in the real world. You can have graphical libraries. So like, you know, when you do JFrames and stuff and Swing is a whole library of different things. You know, you use JFrame in it. That swing.gui is a whole library of different things. And you can have graphical libraries. Now, why do we do that? What's the alternative to do that? Please. Sure, so it's in your language itself, but what, like, if you didn't have the swing.gui library, what would you have to do? You would have to make all of that from scratch by yourself. Disadvantage of that? Time consuming. You're probably going to introduce more errors because hopefully the person who's written the library is an expert, so it's pre-written code written by an expert that's all ready to compile and ready to be used. While if you write it from scratch, no offense to all of us in here, but we're probably going to introduce errors, maybe write in an efficient way, and certainly it's going to take longer. So what do we mean by a library? Well, a library is sections of code. Yes, who was it written by? Yeah, written by expert or anything else? What sort of things are going to be inside it? Well, on the mark scheme, it says useful routines. But I guess if you said something like helpful code that I'm going to use would also be good, wouldn't it? Because that's what we're talking about here. But, you know, useful subroutines, it comes with a whole bunch of different functions for us. Containing useful functions. Have I answered fully the question? Yeah, so what's an example? I just talked about some of the examples. What example are we going to use? Sorry? So I would say, if you use scanner, the only problem is that's in Java. So you could say, I would say, so examples could be, that would be something like a input-output functions. But I'll be honest, What was the one that I said in general that you could use? Graphical libraries, yes? Graphical GUI libraries. That's pretty common. And some of them, so the ones that we looked at and the ones that we use are for GUIs. Of course, if you would like to do 3D rendering, are you going to create your own 3D engine yourself? So you'll be using libraries to allow you to do that kind of rendering as well. Make sense? Okay, other examples they got here: database access routines, encryption, and just general graphics. Yeah, and you can imagine you could have one for like different kind of asymmetric encryption program, so you don't have to create it yourself. It would do it yourself. Brilliant. Okay, advantages. Now, when we're talking about advantages, we had that conversation just now. What's the advantage of the program having a library? Compare that to not having the library at all. If you're going to have to write it yourself if it doesn't exist, what does the library allow? Automatically, it allows you to saves time all day, right? Saves time, and why? Yes. So saves time as because no need to rewrite code. Yeah, I completely agree with you, right? It's going to take me time to write all these out, so maybe I won't write them all out, but I agree with you, is that because it's created by an expert, sorry, there's two advantages. Because it's written by an expert, you potentially can do things that are more sophisticated than you can think off the top of your head. So maybe you don't know how to write that encryption algorithm just like that, but you can utilize that functionality. But also, because it's already been tested, it should be error-free. Yes? Okay, what about disadvantages? Now, I think these questions are always best if you put yourself in the mind's eye of yourself, right? Have you used libraries? Were there any disadvantages? Go. Do you know how they work fully? Not really, right? And that's the disadvantage, yes? Because you've not written yourself. Somebody else has written it in their programming style. You don't necessarily have all of it. And so you've got one here, not written by the programmer yourself. So introduces uncertainty, requires different testing, requires familiarization, yes? Because you're not the expert. If you write the code yourself, you know exactly how it works. Somebody else written the code, yes, they're written by an expert, but you don't fully really understand how it works. And it could introduce errors and bugs because of that. Anything else? That's true, but think about it. Why? Maybe this will help. In Java, you have to write import and bring it in. Why do you have to import it? So for instance, if I use a string, did I have to import the string library to allow me to do it? That's in like the core functionality. Why do I have to import? Why make you import it? What's the alternative? You could put every library in core Java, yes? There we go. So the idea is you want to customize your software so it's only using the functionality it needs. If every single library was available, then when you compile it, would all those libraries have to be compiled with it? Even if you didn't use them. So it may significantly increase the size of the compiled file. Why? As the library contains many routines that aren't being used. Make sense? Do you know, and I realized as well, you've got the actual masking for this, so maybe it's not necessary for me to write these all out, right? But makes sense. And then linkers. So something else I want to talk about, let's put it in context. Linkers, loaders, and libraries is the last step of what process? Bingo. Thank you, Abdul Razak. Compilation. First stage of compilation is you start with human readable source code. Could that be a low-level code if it's using compilation? Yes. No. Low-level code like assembly code is not compiled. It is assembled. High-level code, when it's translated, could either be compiled or what's the alternative? Interpreted. And compiled is what we're going for right now. And of course, you could also be compiled to intermediate code, like bytecode, something like Java, or to object code. I guess we don't know right now. Anyway, compilation goes through several stages. You start with human readable source code. Maybe this is actually more helpful if I do this. So we've got source code. And if we're doing stages of compilation, what's the first thing that has to happen? Do you remember? I mean, ultimately, so yeah, this is human, this is us, readable. So this is basically, in Java, when you see it, that's human readable source code, yes? And that has to become ultimately either intermediate code or object code, ones and zeros, ready to run. There are a few stages. I'll give you some clues. The comments I've made you all write on pain of death, right, for your project, do those comments need to be written? Does the compiler need to read those comments? Who are the comments for? Yourself and other programmers, yes? So is it necessary to feed that into compilation? So what should be removed? All the comments and any white space. It doesn't need that white space either, right? And it needs to turn your if statements and variables into tokens. So like this if statement's a token, this for loop's a token, this while's a token. All of that is called a lexical analysis. Yes? Lexical analysis is when it comments, white space is removed, a symbol table is made of all the different variables and assigned where the memory locations are for it, and all of it is tokenized. Why? Because then it needs to be fed into the next stage. The next stage will throw up errors potentially if you've made a certain type of error. And it is called syntax. Yes? Nope. It is a syntax error, but analysis. So I completely agree with you that we get syntax errors, do we not? That's because they get to this stage and it checks those tokens. So it looks at an if statement. It says, hey, in this if statement, does it return a true or false? It doesn't. Boom. It will throw up a syntax error. And those are all added to a list of error codes that you get at the end. And then you can read all of those. Now, if it fails syntax analysis, what's going to happen? It's going to stop. It will not go to the next stage. Yes? Hence why syntax errors, program does not run. If it does run, it goes to code generation. That's when it turns all of these tokens either into intermediate code or into object code ready to run. And as part of this optimization to try to do that more efficiently. So that's when, there's instructions with opcodes and operands. That happens at code generation. So this is actually a very complicated area of it. But is it ready to run then? Well, no. If you've put in import scanner, is that scanner actually in your source code? No. So a linker links your source code to maybe other classes you've written or to other libraries you've written, ready to actually run. Yes? So that's where linker loaders and things. So linkers, I'll come back full circle. Linkers, I'll just read the mark scheme. Links the main program to libraries, right? And if you didn't link that main program to libraries, it wouldn't be able to run because it'd be like, what the hell is this scanner thing? Or what the hell is this array list thing? And it can either include them in the final executable code or get the executable code to point to the external libraries. What does it mean by that? It means, so this is coming up with all your ones and zeros. You can either stick your library in there so it's embedded altogether, or, and this is actually much more common, the library itself, there's a ones and zero version of it. So there's a version you can see like scanner. There's also a compiled version, and that's actually much more likely that it just links to the code, and so it just has them as separate objects that it's ready to use, as opposed to sticking inside it. Cool? So little man computing, on the theme of low-level programming and high-level programming, is little man computing representative of a low-level program or a high-level programming language? 100% low level, right? And you can see it here, right? We discussed that previously. We said that we've got that one line there. STA is an example of a opcode. Num1 is an example of and it can just convert it directly from little man computing to the whatever machine code ones and zeros for it. Other ways we can classify it, just trying to link it back to other things that we've done. Do you remember we can have reduced instruction set computing, which is aka RISC, and complex instruction set computing, otherwise known as CISC. Is little man computing RISC or CISC? So what is reduced? Is the reduced instruction set. What is the instruction set? It's all the individual opcodes. So if it's reduced, what is it to be reduced? Reduced is something that I need to become probably over the next 10 to 20 years so I can actually live a longer life. Well, shorter or smaller, right? Anyway, so by reduced, are you expecting to see a long list of opcodes or a short list of opcodes? Short. In little man computing, do you have a lot of opcodes? I think you got 9. In your phone, it will be using a RISC processor as well, but maybe it's got 80 instructions. On these computers here, they use CISC, and maybe they've got like a couple of hundred, maybe even 1,000 instructions. And remember, with RISC, the complexity happens at the software level because each of the instructions are very simple. Example, often RISC processors don't have a multiply function, and therefore in the code it has to be able to do it by using combinations of shifts and adds and stuff. Where in CISC, there will be a multiply function, but then the chip itself has to do it on multiple processor cycles. Anyway, shall we go over this? Now, little man computer, I think my tip would be is go back to in your mind's eye, or even draw it out, the actual registers. So we've got a very important register that we're going to have to use, which will be the accumulator. Yes? And the accumulator is going to be what we actually store as we go along. And I think that's a really good one to keep track of and be thinking of. So IMP, which stands for input. So we need to know what on earth is input. Somewhere in here, surely it says. Oh, it just says recreate it with the same thing. So input, the first thing we want to do is, this might be a mistake. I probably should have read over it a little bit more. But I'm just going to say input. But if I just do input like that, what do I need to do? Store it in a variable, which is the next thing. sta num1, it says store it in num1. So if I say something like num1, I'm going to, this is a new low even for me. Okay, num1 equals, right? It will take in whatever the input and store it in the variable num1. Yes? And we've done that on one line because what kind of level language am I using right now? High level language. Well, actually, it's kind of like pseudocode, isn't it, really? Because input, yeah. But the input's totally fine. You can do print, also acceptable. It looks a bit more like Python, in fact, actually, if anything, right? And then, so that's one. And then input, imp, and then, because remember, imp will mean that we stored in the accumulator, and store number 2, it means store the contents of the accumulator at location num2, whatever that is. So I need num2, yeah, forgive me for this is a bit ugly. Num2, what would I do? Equals input. Now, in addition, there are at the bottom where it says dat, you see these? These are variables that have been declared, because actually you can, instead of num1, you can just give a memory location, like 10 or something, but they've done this to make the computer reserve them. So all the instructions will happen first, and then they'll reserve these memory locations. 1 dat 1, what do you reckon that's going to do? Location, wherever that is. And we're going to use it. So I think we should honor that and say 1, the variable 1, is equal to 1. Yes? And then what was the other one? Count. Count is equal to 0. Now, truthfully, we actually might not need those because count's probably going to use as a counter to make it go up by 1 every single time. So we can probably just use a for loop to get around this. Anyway, main, load num1, sub num2 from it. So we load number 1, let's say it's 10, sub 2 from it, let's say it's 6. If it's positive, then say load number 1. Do you see what it's doing? So if num1 is bigger than num2, it will be positive, and then you go here. Store number 1, load the count, add 1, store count, break main. So we've got a loop going on here. So sometimes in these ones here, I think they're better if you just actually plug it with some real numbers, right? Because we need to do a bit of detective work, don't we, about what it's going to be. So shall we say num1 is 10, num2 is 8. Load number 1, so number 1's going to go into accumulator, it'll be the value 10, sub number 2 from it, so a 10 take away 8 is going to give us 2. Branch if positive, Is that positive? So go here, load number 1. So 10 is going to get loaded in there. Load count. Oh, sorry, store num1. But that's not going to do anything because we actually changed it. Oh, no, sorry, my bad. So, my bad. We had 10, take away 2, take away 8 makes it 2. Then the value in the accumulator will be 2. Yes? And then we store num1, we store the difference in there. Yes? Right? Yeah. And then we load count. So what we're going to load into the accumulator is count. Yeah, it is 0, isn't it, right now? Add 1. So we're going to add 1 to it. So where's count? Count, let me just introduce it as another variable. Count will become 1. So 0 became 1. And then BRA stands for branch always. Go back to main, load number 1. So we're going to load 2. And then we're going to take away 8. So it's going to give us the value -6. What's going to happen here? So go to the next one. So not pos. There you go. Load count. So what's going to get put into count? 1. And then output 1 and stop. Okay. Let's try it with some different numbers. I think what it's saying is, I think it's how many times you can divide the one number by the other. So that's my theory. So yeah. So let's do 20 and then 6. Yes. Yeah. Div, integer division. Yeah. So yeah, if we look here, 20 take away 20 take away 6 is going to be 14. If that's positive, count's going to go up by 1 here. Yes. Yeah, and then store, and then num1 become 14. 14 take away 6 is going to be 8. That's positive. Count goes up by 1, so it's 2. And then 8 take away 6 is 2, so it's still positive. So what it is it's division. So the goal, really the challenge here then is that the code's going to be quite straightforward, isn't it, really? It's going to be like, and what do we need to do with it? Just output it, don't we? So it's not mod. Mod is the remainder. Div, yeah. It says the same functionality. So I'm tempted. Yeah, I'm tempted. I don't think I'd have the guts to do this in the real exam. So I probably would do a loop that just counts itself as it's going around. Print num1 div num2. I mean, it does say the same functionality, and you know what I should do? Input 2 numbers, correctly calculate integer division, correctly calculate remainder. Where's remainder come into? Count is the. Oh, do you actually output the remainder as well? Yeah, it does. So you need both. Sorry, my bad. I need to actually read the rest of it. So it does give you both. But then it says, print out both. Can be completed either using mod or div or by using repeated subtraction. Oh, so we can actually go. So if I said something like, sad, I'm not actually brave enough to have done this. I've just confessed as well to you guys. Num1. And what do I do next? Div num2. Exactly.
So if you literally just did out there, num1 minus num2, constantly.
Yeah, in a loop and count it and stuff. You could literally replicate almost exactly that, couldn't you, in a loop? While loop realistically. While num1 is larger than num2, and just yeah. So what's the learning we've taken from this? Here's the learning I would say, and then I'll totally take your question. Is you see what I did here? Where I plugged the communicator. I had create my own numbers, and I went through the experiment of running it. I confessed to you guys, I looked at it immediately. It didn't occur to me immediately what it was doing. But you see that by doing it, by running it through, yeah. So that's going to happen in the real thing with you guys. It's going to happen in the mock, but it's going to happen in the real thing as well, right? That could happen. So my tip is create some real numbers and then play around with it, right? And as soon as I've done that, actually, it's a piece of cake in terms of replicating the functionality, right? Okay, so looking at this question, it's all about making use of recursion. Before we start looking at the question, why don't we think back about what recursion is? So there's essentially two ways to solve an algorithmic problem. One is iteratively, by making use of for loops and while loops. And another way of solving a problem is by using recursion. Now, can we remember what recursion is all about? So yes, recursion is when a subroutine calls itself from within itself. What is the name of this function? That was almost a joke. This function. You see, computer scientists are funny. And being that recursion is when a subroutine calls itself from within itself, we expect to see this function also in here somewhere. Do we see that? Yeah. And that's what forms the loop, is that this function, we call it externally originally, but once it's been called, see, it calls itself, and then that is where it's going to be the loop. Now, differences between iteration and recursion, why don't we just go through them quickly? Iteration, the calculation is done as it steps through the loop. Recursion, that doesn't happen. Do you remember how recursive statements are solved? It takes the calculation and places it on a stack, and it keeps adding the calculations onto the stack. So it doesn't make the calculations, it places the calculation on the stack until what condition happens? Until it gets to the base case or the unwind case. When it reaches that case, then all of the calculations from the stack are popped off, and it reads through all of them, which means that sometimes we can... so a recursive function is put on this stack, and what can happen is that either you never meet the base case, and then what would happen to the recursive algorithm? It would just keep on adding to the stack until you get, name of a famous website for programming, Stack Overflow. And that can actually happen if you do meet the base case, but it goes on for too long. Basically, it gets too deep and you get too many things. Anyway, with that in mind, and also that recursive algorithms are sometimes suitable because you can actually, for certain kind of problems, because they're quite elegant the ways they work, although trace tables are sometimes a pain, which we get to do now. So we see in here, there's an array called the array, points for originality for this guy, here. And the array has an index, standard index starting at 0, and it has 5 is at position 1, 10 is position, 5 at position 0, 10 at position 1, etc. And then this function, so this is the first time it's triggered, sends it the array. Oh, what do we call these things, by the way? Parameters. So it's sending the values, it's sending the array as a parameter value, and then sending 0, 7, and 35. So num1 would be 0, num2 would be 7, num3 would be 35. Hey, how about we just use the trace table? They've helped us out here. They've actually given us a trace table to use. Should we just do that? Yeah. So first time around then, the trace table here, we send these functions. Num1 would be, there we go. Num2 would be, and num3 would be 35. And it says result, but really what we need to do here is like look at this calculation. So it says result equals num1, which is 0. Then we've got this 7 minus 0, so 7. Div, what does kind of division was div again?
That's how many times it divides itself by numbers.
Yeah, no remainder, and it's, so we call it integer division. So if it came out with the answer 7.8, 7.8 would become 7. Yeah, it just chops off the bit, right? And a slash would be real division, so a real number will give it decimal place, and then mod will give the remainder. All right, so 7 minus 0, well, that's 7. Divided by 2 is 3.5, but because it's integer division, we make that 3, and then we have num1 plus that. Well, num1 is 0, so result is 3. Wunderbar. Okay. So, is num2 7 less than 0? No. So we're going on here. Else, if the array result, so result's going to pick out 3, so 3 is going to mean it's going to be the value 20. Yes? Yeah. Is 20 less than num3?
No. Yeah. I thought it was number 7.
For people at home, we had a discussion, but in the end we came to the conclusion that 20 is indeed less than 35. I hear you. So we're going to do this. We're going to return, so this is the recursive element. We're going to call the function again. This time we're going to send it the array, so same as last time. Result plus 1. So what is that going to be? Num1 is result plus 1. So what was result?
3.
Plus 1.
4.
So num1 will be... num2 is... I just muted myself. I don't know how long that was for. Okay. So what do we think this is actually doing, by the way?
I believe it is
0 and 7 are not by accident. They are the first and last index in this array. And then you're presenting it. You looked at the middle number, and you said if it was bigger than lower than another number. It's a, what kind of a search? Binary search. Binary search, isn't it? That's what's going on. Anyway, okay. Anyway, back in here. Now we're saying we have to calculate the result again. Num2 is 7 minus num1, which is 4. So 7 take away 4 is 3 divided by 2. Well, 1.5, but we make that 1 plus num1. And num1 is currently... It says there. 4 plus 1 means result is 5. All right. And then we go through here. We say the array at... so is num2... So num2 is 7. Is that less than number 4? No. This will probably mean that we didn't find it. So -1 probably indicates it's not found in the array. If the array, say result... So what's result? 5. The array at result. So what value is that going to be? I kind of screwed this up a bit, haven't I? 7, 6, 5... What? Oh, you know what? Yeah, no, but that should have been... Oh, no, we said 20 was less than 35. We did do that right, yes? Anyway, because I've gone a bit skew-if. So 7 is 40, 6 is 35, 5 is 30. So 30. Is 30 less than 35? Yeah, still true. Return this function. We're going to call it again. This time the array, and again, result plus 1. So result plus 1 is 6. So num1 would be 6. Num2 would be num3. We recalculate the result. Num2 is 7. Take away 6. So that's 1. Div that by 2. 0. Num1 is 6. So result will be... So we could, because 1 div 2, because it's integer division, well, 1 divided by 2 gives you 0.5, but it's integer division, make it 0. 6 plus 0 gives you 6. This would be 35. Is 35 less than 35? No. Is 35 greater than 35? No. Return result. Return, well, what is result? 6. So what was 6? But what does 6 represent? The index where the thing we were searching for, in this case 35, was found. Okay, software development methodologies. We're talking about the waterfall cycle, spiral, agile, rapid application development. Essentially, you're talking about a bunch of different strategies about how to make software. The big differences are this. Waterfall is nearly always the comparator because it works slightly different to the rest in the idea that waterfall is a linear process starting with analysis. When analysis is finished, you go to design. When design is finished, you go to implementation. When that's finished, you go to testing until you finally get to the end. And the risk for waterfall is that you haven't fully understood what it is your client wanted you to make. So in the analysis phase where you're trying to specify what you're trying to make, if you have misunderstood your client, the next time you speak to your client is when you've made the thing. And that will be an awkward conversation where they go, well, that's not what I meant. Okay, well, that's what you said, but that's not what I meant, backwards and forwards. And then we try to sue each other, which is a fun experience. All the other types are trying to involve the client to a larger degree and have less documentation and more conversation as you go along with your client. So in Spiral, for instance, you go through this phase of basically specifying what you're trying to make, trying to design what you're trying to make it, test it, and then you have a prototype, you have conversations with your client. What is it what they're trying to make? Is this what it is? Oh yes, great. You learn the lessons, and then you go through the whole process again. You make another prototype, right? Agile just takes that and really works on it. Often you have somebody embedded from the team working with you directly, and it's just all about iterating, prototyping. There's very little documentation whatsoever. It's like on this spectrum. So in this case, when we're looking at Spiral, you go through the process of determining the objectives, aka analysis, identify and managing the risk when you're talking about the design of it, make it and test it, plan the next iteration, and then client feedback informs future developments. You get to talk to them. What do you think of this prototype I've just made? What worked about it? What didn't work about it? You're not trying to make something perfect in one go. And that feeds into the next one. Well, waterfall is a structured, linear process that you start at the beginning, you work through the whole process, and the next step's not made until the previous step is completed. It comes with a lot of documentation. So the Power model relies on frequent client feedback. Where on the waterfall cycle is client feedback involved? Analysis when they come up with the specification, and then again, at the end. So waterfall is much more structured and very reliant on getting the definition requirements correct at that start. Changes are harder to add in later stages. However, it forces the definitions to be well understood. And I guess also, it's not on here, but I would say with Spiral, the danger is that you will keep iterating for a while. While waterfall is this very much, we're making this thing, here it is, it's delivered, end. While Spiral, you could always, of course, iterate and make it better. Although you could argue probably in the end, maybe you come with better software. Not guaranteed, though. Spiral involves client feedback, prototyping and involving projects, better options where requirements may change, better option where requirements may change. So yeah, if you've not fully understanding what you're trying to make, it leads it to waterfall, to Spiral, right? Because actually in the discovery of making the prototype, you're going to learn lots of lessons you can apply in the future. If it's something where it's really clear, let's say you've already got something that exists and you wanted to have a version 2 of it, then waterfall is not a bad idea because it's actually quite clear what you're trying to make. You really specify it, you go off, you make it, done. But if it's unclear, you're trying to make something new or something that's not been done before, then Spiral leads itself to it because you actually might learn more about what you're trying to achieve by doing the prototyping. Yeah, waterfall is better where requirements are very clear. Spiral better for risk management. If the program has a large team, that waterfall may be appropriate due to the clearly defined aspects. There's also an element with waterfall, there's a lot more documentation. So if new members come to your team, they can actually get up to speed. Some of these other ones, like Agile in particular, there's less documentation. They get thrown into the middle of it. They might not really understand what the history is or what you're trying to achieve. So because that's often been conversations that have been ongoing. Cool? All right, I said I'd do that pretty rapidly. Oop. So these object-oriented programming questions, a lot of the questions will be things like, can you write a constructor? Can you instantiate an object? Can you use a constructor? And when you instantiate it, can you use the constructor to send it the values, to instantiate the object, the values that that it needs to be created with? Can you do getters and setters? Can you demonstrate a data hiding by doing that? It's these kind of questions that come up a lot. I suppose before we get into the details, what are the 3 principles we need to learn for object orientation? Encapsulation is number 1. Inheritance and polymorphism. So encapsulation is where we wrap the attributes and methods inside the object, and therefore can only access it through those methods. So, for instance, that's why we do data hiding. So we make the age private. Let's say if it's a student, make the age private, and you only accessible through the getters and setters, so you can sort of validate the data to some degree. Making the methods. Should we make the methods private as well? So if you made the age private, the attribute private, should you also make the methods for getting the age and setting the age, should they also be private? No, that would be a terrible idea because then you could literally never access it in any way. So the methods are public, which means that if you're outside of that object, you can access it, but the attributes are private, so you can't access it directly. Inheritance is when you can use extends or implements in Java. I believe the pseudocode is just inherits, where essentially you come up with a class like this. What is this? This is the name of the class. What are these? Attributes. Oh, it actually says it right there. Okay, fine. And the methods. If I inherit board, if something like, I don't know, small board inherits board, what does it inherit? So that's the superclass would be board. The small board would be the subclass or the derived class, what do you get to inherit from the superclass? There you go. You inherit all the attributes and methods of the superclass. I don't think it's in use in this question here. And polymorphism is when you've inherited those things like get grid items, that in the subclass or the derived class, the one that's inherited it from, you can tweak what the things do. So you could tweak what the get grid lines do in the subclass. That's the polymorphism element. If you remember, we had like a dog back in the day. The dog said woof. You had puppy that inherited from dog. It inherited the thing of saying greet by going woof. But in the subclass of the puppy, it goes yeep or yip instead because it doesn't go woof. All right, okay. If you remember. Anyway, in this one here, a text-based computer game allows users to dig for treasure on an island. The island is designed with a grid of 10 rows and 20 columns. 10 by 20, what am I thinking? What kind of data structure might we want to use? And what kind of an array? 2D array. 2D array. And I think that's going to be in here. Each square is given an x and y coordinate. Some of those squares in the grid store the name of a treasure object. Each treasure object has a value, e.g. 100, and a level bronze. So it's got two different values associated with it, so that might be an object itself. A class board is used to store the 10 rows by 20 columns. So you see in here, that's what we've got. The design for the board is attributes and methods shown here. So you've got a grid, which is this array, and then you've got set grid items and get grid items. Okay, and the attribute set is private, so you can't get it. The constructor. So remember, a class. What's the definition of a class? A blueprint or template that doesn't have state. So that's a class. If I want to create a version of it, I go new of that. I create an object. It's called instantiation, and that one has its own state. It has its own values. So currently, what do I set the value? The grid has no values. Yes, because it's a class. But when I make an object of it, I can set some values. The constructor, when you create the object, the constructor is what's called and allows you to set those values directly. Complete the following things. So this is public procedure new, so this is constructor. And it says, initialize each space in the grid to a treasure object with a value as -1 and level as an empty string. So you've got this, it looks like you've got a nested set of for loops that are trying to go along. So the rows, there's 10 rows, yes? So it starts from 0 and it'll go up to 9. I should have asked that as a question. Right, it starts from 0, it goes up to 9, right? Because it's going to go across that way. What about this columns? 0 to 19, right? Because there's 20 columns. So what's going to happen is these nested iterative loops means that you're going to step through every single. You can start at row 0. You're going to go from 0 to 19. Row goes to 1, 0 to 19, 2, 0 to 19, etc. until you've gone through them all. What are we doing as we're going through? So it says in here, something row column with these square brackets. Where do we use square brackets? What uses square brackets? Arrays. So what do we need here? The name of the array. And what is the name of the array? Yeah, I think it is actually literally called the array. I've actually got it here somewhere. I'm trying to make sure I've got the thing. So, yeah. No, I've got the wrong thing here. In this case, it's called... Is it this one here? It's array of treasures, I think. Anyway, 1 second. Let me just check. So, on here, private grid, array of treasures, is saying that that's the data type. So, the name of the array is grid. Okay, so grid. And then, as we go along, we are going to put a new treasure. So, instantiating treasure. We don't have that, so that must be a class somewhere else that we don't really know much about. What does it do inside each of these? What makes it a treasure? It says in here, a treasure is when what happens? So the value as -1. So we've got -1 in each of these, I think. And then as we go along, oh, this is kind of nice. So this row, this is connected, this for loop here. This for loop is connected here. As you go along, the pseudocode for this, so in like Java, it would be for I equals 0, I less than row, I++. In pseudocode, it's for row. They say where you want to start, where you go up to, and then see here where it says next row. That means it's incrementing. So what we're going to go here? Next column. There you go. Question about local variables, global variables, and parameters. Let's just take a moment to remember what we mean by local variables. So local is inside the subroutine, and where is it visible? Only inside that subroutine. Throughout the scope of the code. No, and the subroutine. Yeah. No. So local variable is visible within the scope of the subroutine, and not what's outside it. The global variable is visible throughout the scope of the code, including that subroutine. Now, the only difference of that is if you've got two variables with the same name. So you can actually call a local variable the same name as a global variable. If you have called the local variable by the same name inside the subroutine, then that takes precedent over it. Yeah. Okay. Well. The point I would say is that with local and global variables is about visibility. So looking at the mark scheme, we can see that we're talking about in knowledge and understanding the importance that the local variable only accessible, only visible inside the subroutine, global variable accessed throughout the subroutine, throughout all the subroutines in the program. We didn't talk about parameters. And if we remember, we also need to think about the difference between passing a parameter value to a subroutine either by reference or by value. Essentially, one of the challenges clearly of a local variable is that you might want to use that value or that the contents of that variable in another subroutine. How do you do that? Well, one of them was to use a global variable, and it's visible everywhere. However, it has the downside that is constantly in memory, and also with a global variable, it can be difficult to keep check of its current value. It might not be reset, so it can cause issues. Also, if you want to take that particular subroutine and use it somewhere else for your reusability, if you use global variables, that won't come with it, and therefore it won't be that easy to move from one program to another. So another thing you can use, if you want to use local variables, and you do, is to use parameters. So parameters allow you to pass values into subroutines, and there's two different strategies. One strategy is by value, and one is by reference. Let's just back up very quickly. What we mean is that we have a memory location. That's what a variable is. Let's say that this is somebody's name, so that's the identifier, and then it points to a memory location. Inside that memory location is a value, in this case Bob, and we want to send that to a subroutine. Now, if we pass it by parameter, if we do it by value, here's what happens. You have a fresh, let's say this is the parameter is n. The parameter is n. If we do it by value, the contents of Bob is copied into a new location, memory location. Any changes we make to n changes this new copied version, and if we want to actually send it back in some way, we're going to have to return it, or I guess call another subroutine and send it that way. That is by value. So by value makes a copy, and then that copy means that the original is unchanged. The alternative is to do parameter by reference. By reference means that the original variable name has this memory location. We've got a parameter here called n, and it doesn't make a copy. It points to the original memory location. Then any changes you make to this, so maybe I change Bob to, I don't know, what do I change it to? I change it to Bib. Whoops. If I change it to Bib, not only will it change the value of n to Bib, it will also change the original value of name to Bib. So it would mean that you wouldn't necessarily have to return the value or send it somewhere else, because this way you've sent it the value by reference and it changes the original. This also has upsides and downsides. The upside is, of course, you don't have to return it. You've changed the original, but it actually can make it more difficult to keep, again, a bit like global variables, to keep track of the current value. In Java, which is the main programming language we're using, basically nearly everything is sent by value, certainly primitive data types, and so therefore you change, it makes a copy and changes that. So let's review. Passing by reference sends a pointer to the original value, so this changes when control is returned. Yes. Passing by value sends the copy of the value, so the original will not be changed. Yes, this is what we just discussed. In the application, so this is the context of this board. If a board is local, it can only access in the main program. This will need to be passed on to any sub-programs that be used. So that would be either by returning it or by sending it as another value as a parameter. The board needs to be changed. It will need passing by reference, so the board is updated. If it only needs to be accessed and not changed, it can pass by value. Of course, you could still change it board, but what you'd have to do is you'd have to return it, and when you return it, set it to the new value, which of course is an additional step. So evaluation, if global, this will be present in memory throughout the hence, using more memory, so this was the downside we talked about. However, the board will be required throughout the program, so maybe it's efficient, so yeah, maybe it's worth doing. And I dare say in a lot of code that you're doing in your programming project, I bet you are using a lot of global variables because you are actually using it throughout your code. A lot of you probably even have a two-dimensional array that is global, and therefore that's a good trade-off. If global, then the program may be more straightforward and less likely to have errors with passing the board incorrectly. It may not be updated when it needs to be because, of course, or you may not be aware of the current state of it, which is the downside. Using local means that the board can be manipulated by subprograms without affecting the actual board if needed, for example, to simulate potential changes. Okay, great stuff.